Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 students. I suppose que stay only the student that want to pass, right? I told you, after the test number 2 is a mess. A lot of people fail. A lot of people making mistakes. A lot of people get ridiculous grade. Maybe I suppose get drop. I don't drop. I drop with attendance. Pero for the grade, no. You pay your money, no? And so you don't learn, it's your problem. Yeah, I put F or put D in the final grade.
Professor, I wanted to ask.
You want what?
I have a question.
Go ahead.
Is there any way that there could be an extension on test number 2 online? I just found that test so difficult.
Okay. Any particular problem, talk to me individually. Send email and I make a decision for you, okay?
Okay, thank you.
Who are you?
Brian.
Okay. Email me, please.
I will.
Okay? No, today's lecture. Okay, we start, guy. It's the time. You need to start on time. Entonces, I want to switch into the whiteboard. Okay, I want to do one more problem about the quadratic function, no? This problem, look, this is the quadratic function. This quadratic function is expressed in standard or in vertex form. So we have two possibilities, standard. Standard, very well. And since it's standard, I suppose que A is 3/2, B is 18, and C is 51. And the question say that you want to do the graph of this parabola. The most important point in the parabola is the vertex. And the formula for finding the vertex, remember, is H is equal minus B divided by 2A. I have minus, remember the formula have minus. B is 18 divided by 2 times 3/2. These two are canceled, it's obvious. Or whatever you want, you multiply 2 times 3 is 6, 6 divided by 2 is 3, and 18 divided by 3 is 6, the answer is minus 6. This is the H value. In order to find the K value, you plug in this 6 here into the original equation. No, let me write here. K is equal 3/2 negative 6 squared plus putting off the microphone, please. Let me see who is this making noise. Okay, off. You, Darlene, off microphone, please. Darlene, Tertulien, do you hear me? She's very complicated. Okay, so putting off the microphone, please. No? Because you have to leave my classroom, okay? Entonces 18 multiplication by negative 6 plus 51. Well, negative 6 squared 36. 36 divided by 2 is 18. 18 times 3 is 54. Minus 18 times minus 6 is 108. Negative 108, of course. Plus 51. Entonces 51 and 54 together is 105. 105 minus 108 is negative 3. Entonces the vertex is located at the point, vertex is located at the point negative 6, negative 3. Let me plot that. Negative 6 here, negative 3 here, that one. This is the point, this is the vertex. And this parabola open in what direction? Open up or open down?
Up.
Up, how do you know?
Because it's a positive number.
Who is positive? Who is positive? What is the indicator?
3/2 is positive.
A, very well. A. When the A is positive, that means that this parabola open up like that. So say, okay, I'm going to do a little bit. This is classical example of the homework online. You select arbitrary, for example. You select, for example, you select -5. So you select two value to the right of the vertex and two value to the left of the vertex. This is the typical question, no? Two values enough.
Professor, is the symmetry always 2?
Yeah, absolutely. You're right.
Okay, so no matter what, the axis of symmetry is always a value of 2.
Exactly. This is the axis of symmetry at x equal -2. I know that my parabola open right, like that and like that. Symmetry, we respect this vertical line. Entonces now, let me try to do quickly because the arithmetic part is not important. You put in the calculator, no? Like, suppose you select 1.5. You plug it in the function, you plug it in -5. Entonces, the arithmetic part I skip, guys. The answer is -1.5. Therefore, the point is -5, comma, -1.5. And -5, -1.5, I suppose here, and my second point look like that. -5, 1.5. Using the symmetry property in -7, it's obvious that the answer is the same. We have the point that -7, comma, -1.5. So here. Okay, one more, que es -4. Suppose evaluate the function in -4. -4 is the next point to the right. So it's -4, when you evaluate the function, using the calculator, you plug in -4 in the original function, no? And the answer is 3, positive 3. And likewise, let me plug -4, 3 here. And evaluate in -8, no? Because it's one step to the right, two steps to the right, one step to the left, one step to the, two steps to the left, que es -8, no? It's exactly the same value. Boom, boom. -7, -8, 3. Okay, ready. This is my parabola.
I have a question.
Let me finish.
Go ahead.
Let me finish. This is my parabola. Question. Come on. Come on, miss.
So you have to pick 2 equations to the right and 2 to the left. That's how you got 5, 7, and 4 and 8. Okay, just making sure.
Another question? Everyone understand very well this or no?
Professor.
Please.
Yeah, I have one question.
Please.
So when you use the vertex formula, like in this situation, that's how you get the x, right? And then from there you just plug it in, and that should give you your complete vertex, right?
Absolutely. Okay. You're right. All right, perfect.
Absolutely. Thank you. I just wanted to make sure I was getting it.
I have a question, sir.
Go ahead.
When you're now, why don't we have to find the x and y intercepts in this equation?
Well, good question. Okay. X and Y intercept is important point when you have no any suggestion extra. But in this specific problem, say to you specifically 2 points to the right and 2 points to the left from the vertex. So you try to find, look, and also it's a little bit irrelevant because, for example, the Y intercept is the point 51. The 51 is completely too far. So it's no useful. The widest. So sometimes it's okay, but sometimes not necessarily. This is a typical point. In my opinion, it's an important point. And this point and this point are a little bit complicated because when you put equal to 0, this equation, you apply the quadratic equation. I don't know exactly where the answer is. Okay, so this is the easy way. Not always, depending the question. Si the question specify arbitrary point, okay. Si the question is wider and say, do the graph, okay, what is the important significant point is y-intercept. And the formula is this, x-intercept, the formula is this.
Okay, completely understand. So a good rule of thumb would be if the C value is something astronomical that's not even implied by the graph given,
Yes,
and we don't even have to worry about it.
We need to find another possibility because it's
okay. I understand. That's where I was getting messed up because I was like 51. I had the y-intercept. It's obviously 0 and 51, but I can't. All right, thank you.
That's crazy. If you want to plot in decimal, you can see it's too far. It's completely useless. Okay, clear? Okay, so today, this is just one extra example. Today, basically, I want to discuss application. Application. So now application, I want to show you 1, 2 application, a little bit complicated, and 1 and 2 more easy, similar to the test. Okay, let me try. Let me try to share screen to the PowerPoint. Okay, there you go. Okay. Do you see the PowerPoint? Okay, basically it's optimization problem. And the optimization problem say, look at that. Let me see. Okay. Look. Oh. Okay. Again. This one. Copy please this problem. A parking area is to be constructed adjacent to the road. The developer has purchased 340 feet of fencing. Period. Determine the dimension of the parking lot that would maximize the area, then find the maximum area. So we have a road, and we enclose one specific area. I want to use it for the parking lot. I want to find the dimension of this area to be maximum. This is the idea for the first application problem. Let me go back to the, well, take time, or take a picture, or copy in your notebook quickly, the problem. I switch into the board to solving the problem, right? This is a little bit complicated because no equation is just word problem, blah, 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 blah. And you need to set up the equation first, but it's no big deal. And also solving the problem to optimization. Okay, I can switch into the, okay, I can switch into the board. Board. Okay, board. Erase the board. Good. Okay, what's the idea? The idea is we have road. And we need to control the parking lot here. I don't know exactly what the dimension of this parking lot. But what is my objective? My objective is maximize this area. But we have restriction. What the restriction is, the amount of fencing we have is 340. Okay, so the first thing in this problem, okay, we have no equation, we have no only word problems, is you define variable. Suppose this segment I call X. And this segment I suppose is the same, no? X. And this segment is different, I call Y. So the area, the formula for the area, everyone knows, okay, one rectangle is X times Y. It's a basic geometry, right? Multiplication, length and width. And the perimeter, que es 340, is the fencing, is 2x plus y. Because we have 2x side, x plus y is the total. We have open here because the car, I suppose, can get inside this side. Do you understand equation 1 and do you understand equation 2? Using basic geometry? Yes or no? Good. Now, I try to manipulate this equation. For example, I want to solve for y, so 340 minus 2x equal y, and substitution this y here. So the area is equal x times 340. Instead of y, I substitution by 340 minus 2x. Now you apply distributive property. Therefore, area is equal to 340 x minus 2x squared. Boom. This is my equation. My question is, this equation corresponds with the quadratic function, yes or no? This equation corresponds with the x quadratic function or no?
Yes.
Yes. How do you know? He said yes. Why? How do you know?
Because they have the second exponent to A.
Exactly. Right? Exactly. Now, it's a quadratic function. The clue is exponent 2, right? And could you can identification, suppose it's a standard 4 or it's vertex 4?
Vertex.
Vertex.
Vertex. Let me organize. No, vertex no, because vertex involves parentheses. Okay, let me recall. Vertex y equal a x minus h squared plus k. And the standard is the classical que you very well know, bx plus c, no? This is a standard. The second one is standard. The first one is vertex. We have no parentheses. Entonces, I suppose que no. Okay, entonces, look. Area is equal, let me organize in different way. Minus 2x, I put a quadratic term first. This quadratic, I put in the first, plus 340x, and we have nothing here. It's obvious que A is negative 2, B is 340, and C is 0. In this specific quadratic function. Do you see or no? This is the classic. And the word problem, you understand the problem, you try to set out the equation using the geometry, you manipulate a little bit the algebra, but now in this moment you realize that this is a quadratic function and you need to interpretation the quadratic function. The quadratic function in this case is expressed in standard form, and you identification that A is negative 2, B is 340, and C is missing. That's it. My question is, this corresponds with the parabola or no? This equation corresponds with the parabola or no? Parabola or no? Parabola or no? No. Sergio dice no parabola. Everyone is agree with Sergio? Parabola yes, parabola no.
Parabola yes.
Parabola yes, because any quadratic function is parabola. Okay, parabola yes. Therefore, this parabola open down or open up?
Down.
Down. How do you know it's down? How do you know it's down?
A is equal to
negative. Okay, so this parabola open down like that. And the point que I need to discover in the optimization problem is always the vertex. Because the vertex should be h comma k, no? In that case, it's a maximum. So when the parabola open down, you have a maximum. When the parabola open up, you have minimum. Making sense, right? This is the key idea for the optimization. enquadrar the function. Okay, so the only thing I should do is find the vertex, H and K. H is the formula, the super fantastic formula, super easy and fantastic, minus B over 2A is minus B is 340 divided by 2 times negative 2, no? Because A is negative 2, look, I substitution. Double negative A, immediately analyze how many negative we have. We have 2, and 2 negative is positive. The basic is 340 divided by 4, no? Because 2 times 2 is 4, it's 85. I suppose that the unit in that problem, guys, is feet. Because this is 340 feet offensive. So this is feet. So I find this time this is 85 feet. And this is also 85 feet. In order to find the y value, I don't know if you're using either equation. In my opinion, I using the Easter equation. What's the Easter equation? The Easter equation is this equation. Okay, 340. Okay, in order to find the y, this is x. How do you know it's x? Because remember, h is the x component always, and y, but no, this y, so another y is the k component. Okay. Entonces, y, que es this dimension of the rectangle, is using the formula 340 minus 2 times 85. Is 170 feet. Okay, this does my parking lot dimension is 85, 170. And the area inside, enclosed, is a multiplication of both quantities, 85 times 170. The answer is 14,450 square feet. Okay. What is the final answer of my problem? The final answer is well. To construct this parking garage or parking area, parking lot, I don't know. You construct using this dimension, and immediately this area is equal 14,400 feet, 450 square feet. End the story, guys. Any question? Any question? Confusing? I try to motivate a little bit, no? It's a word problem, optimization, case solving using quadratic function, no? In this case was maximum because the parabola opened down. Okay. Another problem, no. Another problem is minimum because the parabola opened up. Okay. Let's see another example. Suppose. Okay, I want to copy no PowerPoint. I copy directly in the blog. Any question? I want to hear a question. No, it was clear the explanation, but in the test, I don't put too hard like that. No. I put more easy because the function is given, no? The function is given. Look at that. Let me erase the board. Application number, this was application number 1, now application number 2. Application number 2 is relatively easy. Suppose the problem say, suppose that the manufacturer of something, I don't care, it's a dryer, something, has found that the unit price that the manufacturer produce something, no? And the thing they produce is called a unit. I don't know exactly what is that. Unit price is P. The P represents unit price. I don't know, $50, $200, in dollar. And he studied statistics and discovered that the revenue, I want to call capital R, in dollar also, is expressed in this equation. Revenue for any P unit price is equal -4 P squared plus 4,000 P. Microphone off. The question is, what unit price, P in other words, should be established for maximize revenue. And also one extra question, what is the maximum revenue? Period. Okay, you see, the problem talk about manufacturing produce something, items, unit, they call it unit. I need to investigate what is the price of this unit price, P, in dollar. I don't know if it's $1, $2, $5, $10, $50. But they discover statistically the equation for the revenue. And you discover, wow, the equation for the revenue is the quadratic function. Yes or no? Is a quadratic function, yes or no? Yes. Yes. Very well. Entonces, this is a parabola, right? This is a parabola, yes. And this parabola open down, open up. Open down, open up.
Down.
Down, because you can see your identification. A is -4, no? B is 4,000. And C is missing again. It's 0. Okay. I suppose in the word problem, C is always missing. No, not necessarily. Depending. And this problem was a coincidence. In order to optimize to get the maximum, because it's a parabola, and remember in the vertex we have the maximum, I apply the formula. The formula is H is equal minus B over 2A. Minus B, que es 4,000 divided by 2 times A, que es -4. Double negative become positive, and 4,000 divided by A, 2 times 4 is A, is 500. 500 something, no? 500, I don't know, what is that? 500, this is dollar, this is the unit, what this is, I don't know. What is that? Look, this is H. H is associated always with the X value. But X value in our word problem is no X, it's P. So our independent variable is P. And P, remember, represents in dollar. So this is $500. This is the price of the only one unit. I don't know, maybe it's computer or laptop, I don't know exactly. I don't care. In order to find the revenue, maximum revenue, when you produce this unit, the optimal price is $500, you plug in $500 into the equation. To answer the second question is what the maximum revenue is. -4, 500 squared plus 4,000 multiplication by 500. Okay, put in a calculator, and the answer is 1 million. 1, 2, 3, 2. And this is the maximum revenue when you sell the product using this price, unit price, so the price of the one computer, one laptop, I don't know. Do you understand very well this? It's easy. This is a typical problem you can see in the test. I don't know si es computer, si es video, si es Donna, something like that. Do you want to see one more problem? Yeah, one more easy. Do you follow me or no? Or you are lost? Huh? Everyone follow me or no? Follow, clear. Okay, entonces this is no big deal for us. We need to concern it for another more complicated thing, but this is too easy. One more example. I want to erase. One more example, okay, but this is different because it's like a minimum, no maximum. Okay, the cost. The cost. In dollar, of course. Of manufacturing. X. Cell phone. Wow, cell phone. In thousand. And the formula, the cost is in dollar. But in the formula, the cell phone, they call X, is no one cell phone, you know, 1,000 cell phone. It's given by. Column, and we have a formula, cost for any X value, like a function notation, no? F5 X squared minus 200X plus 4,000. This is the formula. Okay, entonces my question is, this is quadratic function, yes or no? Tell me, any help? ¿Es
Yes.
quadratic function? Yes, it is. Es a quadratic function. Entonces, this is a parabola or no?
Yes, because it opens up.
Very well. This parabola open up or open down? This parabola open up or open down?
Up.
Open?
Up,
Up. How do you know it's up?
because it's positive.
Who is positive?
A.
5.
A is positive. Because A is positive.
Yes.
A is 5, B is negative 200, and C is 4,000. Okay? Entonces, in this case, the parabola can open up, have a minimum, que es exactly the thing I want to find, because I need to minimize the cost, no? The cost is bad guy, no? I need to reduce in the manufacturer the cost. So optimization means minimize the cost. And the minimum is located always in C quadratic function in the vertex. So the formula is H is equal minus B divided by 2A. Do you see that this formula is easy and useful? So minus B is negative 200 divided by 2 times 5. This is 2 times 5, no? 2 times 5. 2 times 5 is 10, es 20, no? Es 20. Es 20, pero es doble minus become positive, so es 200 divided by 20, es 10.
Professor, 2 times 5 is 10.
2 times 7. Where come from this 7? 2 times 5, no?
Yeah, but Professor, 2 times 5 is 10.
It's 10, you're right. Hello. Entonces,
That's
20.
why I was like a little...
It's 20, it's 20, it's 20. It's 20. But 2 times 5 is 10, it's obvious. And 200 divided by 10 is 20. 20 is H, and H is X. Entonces, that means 20 means X value, EX, and our problem is 1,000 of cell phone. So basically, the optimum is to sell, to manufacturing 20,000 of cell phone. It's the optimum. Now, the revenue, no, the cost for this manufacturer is evaluate the function in 20. So says 5 by 20 squared minus 200 times 20 plus 4,000. Let me put in my calculator. 20 squared is 400, no? 20 times 20 is 400. 400 times 5. 400 times 5 is 2,000. Minus, this is 2 times 2 is 4, 4,000. And this is 4,000. Positive 4,000 and negative 4,000 is cancelled. The answer is 2,000. 2,000 in this case is cost, entonces $. Okay, entonces the cost to manufacturing include salary, include the material to manufacture 20 cell phone. Of course, this is in series in the factory is $2,000. This is science fiction, no? Because it's too cheaper. But okay, it's a word problem that I create for you. Any question? Confusing or no? Let me ask a question. Some of you need to take physics in your major, physics? Or no? Never, physics.
Without
No,
calculus.
physics. Calculus, yes, pero physics, no?
Yes.
Yes. Do you want to see another application que I like so much? It's funny. It's the projectile motion. Projectile motion. Projectile motion. Let me show you. It's easy. I bring the simulation que es funny. Look, let me show you. Pay attention, que es funny. Projectile motion. Suppose que we have here. Suppose que we have here a cannon. Launch a volley, and the trajectory of this is a parabola. So it's super interesting. You know the velocity of the bullet. You have the angle of the inclination angle. You have the height of this. And you need to find the maximum range, horizontal range, and the maximum height. And this problem, specifically, the age is, let me put the number, it's 10 meters. The height is 10 meters. The velocity is 10 again, 10 meters per second. What more information we have? And the angle is 45 degrees. Oh, 45 degrees. For this condition, I need to find the maximum range and the maximum height. Okay, do you understand the idea? The basic idea? Entonces, the formula, when you took physics, you understand very well the physics. The formula is, okay, the velocity is a vector, be null. Put null because it's initial. And you break it down or decompose in two components. One horizontal component I call x, and one vertical is y. This is the summation of the vector. But the formula is, for the y position is to pick any point. This point is x, y. This distance is y, the vertical distance. And this distance from the cannon is x. Is equal h plus b null y t minus 1/2 the gravity t squared. X is equal b null xt. This is a different formula for the y and the x, because in the y is different because we have the gravity here. Okay, the gravity always pulling down. The gravity is g. In the international system is 9.8 meters per second squared. But don't worry for this. This is physics. You do physics in your moment. I translate the physics equation to the algebra. Is the important thing for us. So y component is 10 because h is 10. The velocity is 10, but when you break it down in two components, it's 7.07. And 7.07 is the same because it's 45 degrees. Yeah. And we have one isosceles triangle like that. Okay, the hypotenuse is 10, 7.07, 7.07. Now this component is a coincidence get the same, 0.07. T, the gravity is 9.8 divided by 2 is minus 4.9 T squared. This is the equation for the position Y. And the equation for the position X is easy. Is 7.07. It's a coincidence T. Right? Suppose I want to find the total time. Who is T? Professor, who is T? T is a time. Time in seconds. Suppose I want to find the total flight, the total time flight of this bullet. Well, okay, I suppose at the beginning, here, when they launch the bullet, T is 0. When the bullet hit the ground here, T is equal, I don't know. But it's easy to determine this time because you take the equation of the Y and you put equal to 0. Esta parábola, look, esta parábola, si I suppose that this is the floor is the x-axis, so at this point is when the x is 0, y is 0, sorry, y is 0. No high. And you have here quadratic equation. You solve the quadratic equation using the quadratic formula. I want to skip this algebra because it's easy. And we have two solutions. One solution is t equal minus 0.8, and another solution is t equal 2.3, 3 to 1. And this is second, because it's time, second. This solution have no sense because negative time is impossible. The time is always positive. The time travel in only one direction. Now, if you want to find the maximum range, use substitution this time, get the total time in the x equation. So x maximum is equal to 7.07 multiplication by 2.321. And the answer is 16.41. I suppose it's meter. And this distance, in this example with this condition, is 16.41 meter. And
please repeat that with the unit you'd like to convert to.
And also, curiosity, just curiosity. If you want to find, go ahead.
Is anyone else's mind blown that he actually did that in his head? The professor did that in his head and not on a calculator. I'm sorry. Am I the only one that's my eyes are wide open right now?
No. You know, I skip the arithmetic part because I need to save time.
That what I'm saying is that you did that in your head, and I'm still trying to.
No. I did in my paper. Yeah, I write directly here. If you want, I spend time, but no.
No. It's okay. I'm not...
Basically, Jordan, the thing we are doing is determine A, B, C. A is negative 4.9, B is 7.07, and the quadratic equation, C is 10. And apply the famous quadratic formula. And we get two solutions, this solution and this solution. Okay, physically, I care the positive solution because the time is always positive. And just plug it in here, and the equation of the x is determine the maximum range. Okay. The funny part, maybe it's confusing, you don't understand very well because it's the physics, no? I bring the simulator to illustrate this idea. Look, 16.41, remember, this is important value, 1641 meter. Okay, I bring a simulator I found on internet about the, let me show you share the screen with this simulator. Okay, the student get one to see this simulation. Let me know if I can help to find internet and you download if you want. Okay, you see the Canon. Do you see Canon? Do you see the simulator? Yes. Okay, look at that. So this is my Canon. Remember, I can set up the height. Okay, 10 meters, no? And my problem, I computer using 10 meters. And the initial speed is 10 also. 10 meters per second. And the angle was 45 degrees, no? 45 degrees. And the maximum range was, I forgot that value is 16.41, no? 16.4 is okay. 16.4 is okay. Okay, here, when I press this button, I launch the ball. Look at that. Pay attention now. Boom. Pow! I got it, right? This is another application of the, let me use in this tool. In this tool, you can see, for example, the time. Okay, it's the same time that we compute in the quadratic equation, 2.32 seconds. The range, 16.41, nice. And the height is 0 because hit the ground, no? One extra credit for you. Try to find the maximum height. The maximum height is the vertex of this parabola using the formula for the vector. But this is extra credit for you. Not necessarily do it now, guys. You focus in the homework. Is 5.1 the distance in x range is x, height is y, this distance is 12.55, and the time occur at 0.72 seconds. So try to simulate mathematically in your paper this parabola. You have the equation, and try to find the maximum height. Okay, so you want, you present to me inside the test, like extra credit. Okay, I give you 10 extra points. Find the maximum height. Do you like this or no? Was good or no? No? You don't like, huh?
Do you mind putting that?
She said, no, I don't like. No, Flora, no problem. This is just, to illustrate the application. So
I want to get on so I can input the maximum.
Maximum height. So basically, the thing I want to find is this distance. Wow, this distance. So 3 parameters, no? At what time is this? Remember, this time I found was 2.32. But this is smaller, I don't know. This distance is x, and this distance is y. By the way, this is a y maximum, because it's the maximum height. Okay? 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 Okay, now today we start new topic. Today we start new topic. This new topic is very complicated. Very, very, very. Okay, quadratic function is super easy, but the new one that we study is more complicated. Okay, it's about rational function. Rational function. Okay. Number 1 definition. What is that? Rational function is the division to polynomial. Look. This is P and this is Q. I don't know why the book called it this way. PQ. P is the numerator top and Q is the denominator. Wow. And Q and P are polynomial. P and Q both are in general polynomial form. But I want to put example to illustrate different possibilities. And throughout the topic, we discuss it more and more and more and more and more characteristic, because this is very, very complicated. Yeah, this introduction gets to introduce more difficult, complicated. Okay, suppose I want to go put example functions. The original function that's given in the test. I copy here in the second column a factory form of the function. The basic a factorization. No? One function is given, and you factor the top part, and you factor the bottom part. It's a factory form. And why not investigate domain? Because it's completely different to the quadratic function. Quadratic function domain, you know, it's always all real number. And the rational, no. Surprise. Let me start for example one. Example one is elementary. F of x is equal 1 over x. One in the top we have 1. 1 is a polynomial, but polynomial degree 0. And x is a polynomial degree 1. The factor form stays the same. Because we cannot factorization more. Break it down 1, break it down x. No, it's the same. And the domain is obvious, is all real number except 0, because division by 0. Remember the famous restriction that we studied, p divided by q, and q not 0. In this case, q is x. So it is all real number except 0. 0 is the only bad guy that we have in this function. How you express this? Well, there are many ways to express this. In English is all real number except 0, no? In more sophisticated mathematical language, you write like that. It's x such that x not 0. This is one possibility. I like so much in the test as you interval notation. And the interval notation is from negative infinity, comma 0, parenthesis, union, 0, comma infinity. Because, remember, this is my all real number line, infinity to the right, minus infinity to the left, and we have immediately here one hole. And the hole is 0. Okay, so the domain is that part. And that part. Pero no 0. That this interval represents that piece. This interval represents this piece. Entonces, two intervals separately. Okay, you know, we connecting by this symbol indicate union. Everyone follow me so far? Easy example. Suppose the second. Yes, super. Suppose the second is 5x squared divided by x squared minus 5x plus 6. This is the original. And the factor form, well, okay. The only thing you should do is factorization. But on the top, we have monomial, stay the same. And the bottom, we have a famous trinomial that you can factorization. And the combination is 3 and 2. Both negative, right? And the okay. So negative 3 and negative 2 multiplication is positive 6. And negative 3 plus negative 2 is negative 5 addition. Okay. Now I apply the same idea. Look, this idea. I realize that the number get to be undefined, the function is 3 and 2, because you're plugging in 3 here, 3 minus 3 is 0, or 2 minus 2 is 0, is division by 0. Therefore, the domain is all real number except 3 and 2. 3 and 2 in this example are the bad guy. You can write in English, you can write in this notation. Let me write this notation, it's countable. No 3, comma, no 2. This is perfect. And you call this domain. Domain of what? Domain of G. Okay. Okay. I like that. Okay. I bring
Really
two.
quick,
Go ahead.
Why is that not -3 and -2? Just real quick, if you don't mind.
Because 3 and 2 are the value that when you try to plug it into the denominator becomes 0. 3 minus 3, look at that. Suppose x equals 3. 3 minus 3. 3 minus 2. 3 minus 3 is 0. 0 times 1 is 0. Division by 0, undefined. This guy is completely out of the domain. Likewise, 2. 2 minus 3. 2 minus 2. 2 minus 3, negative 1. 2 minus 2 is 0. Multiplication by 0. Again, 0 in the denominator, undefined. Mistake. Error. Bad guy. Any question?
No, got it.
Okay. Remember, it's easy. When you have a division, you try to investigate the polynomial in the bottom. The value get to be 0, the polynomial in the bottom. Okay, let me go to number 3. Number 3, the function is called h of x is equal x plus 3 divided by x squared plus 4. Let me try to factorization. Well, on the top, we can do nothing because it's only one binomial, it stays the same. And the bottom is a binomial also, but it's plus. When it's plus, it's totally irreducible quadratic. So it stays the same. Why? Let me try to explain this. Suppose the classical x squared minus 4, okay, the difference of a square. The factorization is xx, because the square root x squared is x, and the square root 4 is 2 plus or minus. Now this obey to this famous formula, okay, suppose that you remember very well. A plus b, a minus b. Yes or no? But what happens if it's plus? Like this example, it's x squared plus 4. Pues it's impossible, guys. The factorization, at least in the real field. This is prime expression. Suppose another point of view. Suppose another point of view. Suppose that I have no idea of that part. You take the polynomial in the bottom. You enforce it to be 0 because I want to investigate the bad guy. And you solving this quadratic equation. The best way for solving this quadratic equation is solve for x squared. I move forward to the right hand side. Apply square root both sides. X is equal, square root negative 4 is plus or minus 2i. It's imaginary. And remember, I say you, that when you try in algebra to find something, and the answer is imaginary or complex, it's because what? Because what? It doesn't exist. Very well. It doesn't exist. Okay, so let me summarize at the beginning. The professor give me one example 3. I try to investigate. I cannot factorization. And when I enforce it to be 0, the answer is imaginary. That means that we have no bad guy. We have no restriction. So my question is, what is the domain of this function? Let me repeat again. Remember, the idea I repeat throughout the semester several times is domain of the some function is the supposition is all real number except the restriction. This is a classical definition. Now, it's all real number. So I try to find the restriction in this specific example. Yeah, I found it do not exist. The restriction do not exist because the restriction living in another planet, in Jupiter maybe, is imaginary, right? So what is the domain then? In English, give me what is the domain in this case? All real number. You put in English, all real number, because there are no restriction. Suppose that the professor asked me in interval notation from negative infinity to positive infinity. Parenthesis. Okay, super. Example. The last one, I promise. The last one of this part. No? Number 4. The name of the function is p. P of x is equal x squared minus 11x plus 30. Polynomial. In this case, trinomial. Another is x squared minus 9x plus 18. Guys, by the way, we are recording the lecture or no? Let me see. Yeah, we are recording. Okay. This is the original, just give it in the test. What should I do? What should I do? What should I do? In order to express, come on.
You're gonna factor the top and factor the bottom.
Exactly. In factor 4, you apply factorization, trinomial. The variable is x, for x.
So you get x minus 6 and x plus 5.
6 and 5, you say get negative both? Yes, you're right. And the second one, 18 and 9.
6 and 3.
6 and 3. What sign?
You can make them both
right?
negative, right?
Yeah. You're right. And you can see in this particular example, I bring intentionally with this idea. Look, one factor is canceled because x minus c is canceled. And the answer so far is x minus 5 divided by x minus 3. Okay, and this function is equivalent to the original function, equivalent 99.99%, not 100. I want to explain in detail this idea. Okay, entonces let me continue. What is the domain? What is the domain of this original function that the professor gave me in the example 4? Is all real number, and who is the bad guy? Who is the bad guy?
5 and 3.
5 and 3. No. 5 and 3. No. Remember. When you have division, P divided by Q, the restriction. I don't care P. I don't touch P. P is nice. Nice. The bad guy is Q. Q no 0. I never touch the top part. Entonces, okay. Flora dice, okay. Entonces, what is the domain? The domain is, okay, the domain junior don't say. The domain professor is all real number except 3. Well, no. You are semi-right, not totally right. Domain is all real number except the restriction, but the restriction of the original. And the restriction for the original is no 6 and no 3. We have 2 restrictions. Okay, you cancel out, but you cancel out under the supposition que es no 6. Because look at what happens. Si es 6, es 0 times something, que es 1, 6 minus 5, divided by times something, que es 6 minus 3, que es 3. And you can cancel out this 0 or no? Arithmetic speaking. 0 times 1 is 0. 0 times 3 is 0. Is 0 divided by 0. What the hell is that? Okay? I have no idea. It's also undefined. Okay? If you cancel out the 0, you are making a mistake. So you cancel out this x minus 6 under the supposition que never is 6. Like that. And the remaining part is minus 3. Okay. Si es 3, again, is division by 0. Entonces, the domain is all real number except. Entonces, we study in detail the differences between these factors, que sometimes you cancel or sometimes no, and this factor gets no cancel. Okay, I want to explain that this is like a vertical, look like a vertical asymptote. I want to explain now. And this is no vertical asymptote. This is a hole. And you need to understand very well, not today, I suppose, the difference between holes and vertical asymptote. Okay? This is new, completely new thing. It's particular only for the rational function. Asymptote. This is a new word. I don't know if you hear before or no. But asymptote is totally new. It's just for rational function is the topic we're discussing. Okay. Any questions so far? Question. Junior Dor, are you there? No question. Okay, good, good. Luna, Launa. Junior Dor is there or no? Junior. Okay. Yes, I want to talk to you after the class, okay? Junior, stay after the class. When the class is over, okay? Okay, okay, super. Okay, guys. So now, definitely, I introduce a little bit now about the new topic. New topic, no. It's the same topic, but basically, what is the vertical acid? Oof. Extremely complicated. Vertical acid. Let me explain definition. Vertical acid. We have 4 kinds of vertical acid. Let me try to do a sketch to understand vertical acid. We have 4. It's easy to determine. Okay, this is the value in which, okay, suppose okay, we have a function, I don't know, 1 over x minus 3. I don't care. Remember, I don't care the top part. It's not important. The important part is the denominator. And 3 is totally undefined. So you try to evaluate the function n3, 1 over 3 minus 3 is 1 over 0. 1 over 0, what is that? Well, the answer 1 over 0. The answer 1 over 0 have no answer because it's undefined. Why is undefined? Because we have vertical acid. Suppose the function n3. I don't know exactly, but n3, 1, 2, 3, we have the vertical acid. So the vertical acid always we represent using vertical line, using dotted line. 1, 2, 3. And what is the reason I put 4 rectangular coordinates? Because they are, suppose one typical vertical acid look like that. Boom, boom, is the curve. So this is the curve. This is the function. Don't worry for this example. We cover several examples, but we have different possibilities. One possibility is like that. Another possibility is like that. Another possibility is like that. But the most important I want to illustrate is when the function you evaluate, you approach it to the value, okay, 3 in this case, the value of the function increasing forever. It's go to the positive infinity in this direction, or go to the negative infinity. In this case, it's opposite, no? When you approach it to the right, go to the positive infinity. When you approach it to the left, go to the negative infinity. In this case, right and left approach it both to the positive infinity, and in this case, approach them both to the negative. And how do you know that? It's easy. Let's see an example. I promise. This is a theoretical part. Theoretical. You, for example, you determine the vertical acid. How you determine the vertical acid? You take the polynomial in the bottom, put equal to 0, x equal 3. And you are doing the dotted line. Entonces, to find the shape of the vertical acid is easy. You evaluate in 2 points before and after. Suppose in 3, you evaluate in 2 y en 4. Si when you evaluate in 2 es positive y en 4 es negative, it's like that. If when you evaluate here in 2 and 4 is negative first and positive second, it's like that. See, in 2 and 4, you evaluate both positive, look like that. Both negative, look like that. Okay? Okay. I suppose we have time to do at least one example. Guys, this is complicated, but I cannot explain in few minutes the big picture. So little by little, you understand the idea. You try to find the sense little by little with different examples. Let me try example one, and that's it for today. Example one. Suppose que example one, this function is given. F of x is equal to over x minus 3. And what's the question? Try to do roughly sketch of that function. So roughly the graph by hand in the piece of paper. No using decimal. After we using both paper and decimal. So, okay, it's important to understand that the first step is find the Vertex asymptote. And the Vertex asymptote is always the same. You take the polynomial in the bottom, so in general, P over Q, you take Q and you enforce it to be 0. This is the formula to find Vertex asymptote. In our specific example, is x minus 3 equal to 0, x equal to 3. And this is a line. I do my rectangular coordinate system. Look at that. I know at 3, 1, 2, 3, we have a vertical line. And vertical asymptote. And vertical asymptote always we are doing in black color dotted line. So I have no idea. I evaluate in 2 and 4 the original function. Evaluate in 2 is 2 over 2 minus 3 is 2 over negative 1 is negative 2. Oh, entonces 2 negative 1. Negative 1 is here. 2 negative 1. Y evaluate in 4 is 2 over 4 minus 3. 2 over 1 es positive 2. Es positive, negative 2, ¿no? Sorry. Carajo. Okay, es negative 2. Entonces that point was 2, negative 2. So this is the x value and this is the y value. And this point was 4, positive 2. Now good. Entonces no 1, it's 2, it's negative 2 is here. And the point is here. And 4, 2 is 1, 2, 1, 2. Here. Okay. Entonces my curve approximate, roughly sketch, look like that. I promise that we study more detail inside this, like a y in a z, you know the formula, like x in a z, you know the formula to complete the graph. And another more complicated, like a horizontal asymptote. So we study also horizontal, but this is next time. And another asymptote that we discovered in the chapter. Okay? Okay? Too much for one day, guys. Enough. I repeat this example in detail next time and using decimals to illustrate very well. Okay? Okay, see you.